Hi, so we're going to start with chapter 19. I'll share my screen so that we can rock and roll. All righty, so the first example that we're going to look at is bucketing our costs into fixed, variable, or mixed. So we'll move through this one pretty quickly. So just want you guys to get acclimated to being able to bucket costs. So the first one, fabric for sofa covering. So we're a furniture manufacturer who manufactures sofas for several major retail chains. So I would imagine that the more sofas that we cover, the more material we need. So that's a variable. Wood for framing the sofas. Again, the more sofas we make, legal fees paid to attorneys in defense of the company in a patent infringement suit, 25,000 plus 160 per hour. So remember we talked about mixed costs where you have a fixed portion as well as a per hour portion. So this would be a mixed cost. Salary of production supervisor. We know supervisors have a set salary, so that's fixed. Cartons used to ship sofas. The more cartons, so that's variable. Rent on experimental equipment, 50 for every sofa produced. So although this is rent, because it's per sofa, it will be variable. Straight line depreciation, we know depreciation is fixed. Rental cost of warehouse, we said rent is fixed. Property taxes on equipment, that's fixed. Insurance premiums, $25 per year plus $25 per 25,000 of insured value over 16 million. So that is mixed because you have a flat fee and then a per item fee. Spring for seat cushions, the more seat cushions you make, the more you need springs. Consulting fee of 120, that is a fixed fee. Electricity cost, $13 13 cents per kilowatt per hour. So that's a variable cost. Salesperson salary, 80,000 plus 4%. So this is where someone is getting commission. So this is a mixed cost. You have a flat plus variable. Foam rubber, variable. Janitorial supplies, 25 per month. That's a flat fee. That's fixed. Employer FICA taxes, it's fixed. Salary of designers, we know designers is a fixed cost. Wages would be direct labor, which is variable, and sewing supplies would be variable. So let's check our work, my friends, and we have done good. All right, let's go to the next one. So this one is where we're going to be looking at sales mix and break-even sales. So we have two products, frozen pizza for Norfolk Frozen Foods. They have 12-inch and 16-inch pizzas, and the estimated fixed cost for the current year is $46,800. So we've been asked to do the break-even point for not only for the enterprise, well, for the two products, which is going to be our enterprise product. So I'm actually going to copy this information over to Excel so that we can work this out together. I'll create a new tab. So we know that we first have to determine what the enterprise unit selling price is, unit variable cost is, and the unit contribution margin. So unit selling price of E, unit variable cost of E, and then unit contribution margin of E. So we know in order to get that, we have to take the unit selling price of product A times its sales mix plus the unit selling price of product B times the sales mix to get that. So what we're gonna do is take $12 times 0.30% plus $15 times 70%, because that's the sales mix. So our unit selling price is going to be $14.1. Then we do the same for the unit variable cost. We take 3 times 30% because it is the unit variable cost plus $4 because that's the unit variable cost, and the sales mix for that one is 70, and we get $3.70. And so our contribution margin for E is this minus this, and it gives us $10.40. Now we know that our formula is fixed cost divided by the unit contribution margin. So it says our fixed cost is $46,800. And so $46,800 divided by $10.40 tells me I must sell $4,500 units in order to break even. But it doesn't tell me how many 12-inch pieces or 16-inch. I have to then take this number and multiply times the sales mix to see how much I will sell a 12-inch. So I'm gonna copy my 12-inch down here. So 12-inch would be equals 4,500 times 30%, which is the sales mix. And then the 16-inch would be 4,500 times 70%, which is the sales mix. And I like to sum it just to make sure that we come up with 4,500. So now this is our number. So we're gonna go back and put this into our model. So we need to sell 4,500 units. We calculated that. So 12, it would be 13. The 12-inch is 1350. And then the 16-inch is 3150. Right, it's the bigger number. So now it says, assume that the sales mix was 50% and 50%. Now we have a different number. So we're gonna go back over here, and I like to think smarter, work smarter. So if this was 30/50, I'm gonna copy these numbers and do 50/50. So 12, so now the new sales mix is 50/50. And so again, I like to work a little smarter. And then we do 50/50 here. It didn't say that the rates change, it just says the sales mix change. And now our new item is $10 versus the $10.40. So now we take our 46,800 divided by 10. I forgot my equal sign. And now we must sell 4680 to break even. And then let's just do our 4680 times 50. So it'd be 2340 of each product. Now let's go put these numbers in over here. So we said 4680, right? So it says the break-even point is lower or higher, the same in scenario part 1. So it's actually lower, right? It's lower because the sales mix is weighted more, or is it weighted less? It's weighted less towards the product with the higher, what is it? Contribution margin per unit. Let's check our work. Oh, Lord, the break-even point is, oh, the break-even point is higher. I mean, this is the break-even point. Oh, in this scenario, I'm sorry, I was reading in scenario, in this scenario in part one, because so it's higher in this one than up here. So there you have it, my friends. Those are examples.